Mhm. Okay, thanks a lot. Hello, everybody. Welcome to the event. My name is Pavol. I'm the CTO and co-founder of LatticeFlow. Technical background, I did my PhD at ETH, working on the topics robustness and trustworthiness. And this is kind of how we started LatticeFlow. And this is kind of our mission of the company to really empower companies to enable them to build trustworthy, high performance and robust AI systems. And it's not just me, there is two other professors who are co-founders of the company and been really working on this topic for the last 5, 6, 7, 8 years, and really now trying to bring it from the research to the industry and to the practice. And when we talk about robustness and trustworthiness, we typically think about 3 pillars. And the 3 pillars, when we kind of develop these kind of models, is on one hand, you have the data. And here, it's all about kind of diagnosing and improving your data. On the second part, you have models, where it's all about kind of figuring out, is there some hidden issues in the model, or what we call blind spots, essentially, when the model is systematically making mistakes, but you actually don't know because it's kind of hidden, because you have millions of examples, and essentially you don't know about it, all the way to essentially regulatory part, where you want to formally reason about the models. And what we do technically is really the technical part of the regulations, where someone actually has to check that the model is doing the right thing, not just write on paper essentially what is the process, which is extremely important, but essentially it's always 2 sides. On one hand is the process, on the other one is the technical part. And what better way to show you than with an example? And one of the reasons that we are all here is essentially because of this. So there is a huge potential of AI, and this is what all the companies kind of figured out, which really revolutionized how many of the products are built. And this is really because these systems are essentially reaching or even outperforming human performance. So there is a clear value here, but at the same time, there are some issues. And what are the issues? Well, I will show you kind of one short clip of one race of autonomous cars. So these are essentially competition of cars that are driving autonomously. And this is what happened in the second round. So this is kind of an illustration of what happens in the real world. And this is an event where clearly people spend incredible amount of time, effort, and money to make this work, and yet this happens. And the main problem with this is that this is very visual. Like the car literally crashed into the wall, and they probably had to spend half a year to build a new one. In many real-world AI systems, the AI system is not crashing into the wall, which is the problem because the things are not so visible, like in this case. And that's kind of the problem of this hidden problem and kind of hidden issues of the model that are not so easy to figure out. And this is also one of the problems that even though there is huge potential and huge value in the systems, actually, if you look at the statistics, roughly 80–90% of these projects actually fail. And this is kind of one of the problem where on one hand, there is a huge potential, but on the other hand, there is kind of struggle translating this potential into the practice in many of the cases. So how can we essentially take this example and put it in the practice? And this is, for example, what we did last month when we presented at ECR. This is the biggest radiology conference in Europe with more than 20,000 attendees in Vienna. And what happens, so this is radiology conference, so these are mostly doctors that spend their days kind of looking at images like this, where they have an X-ray, in this case of a chest, and they will try to figure out essentially, is there anything wrong with the patient? And what happened in the last few years is that kind of in addition to all these doctors, there are now companies building AI models trying to do the same thing, right? So the model will take exactly the same picture as the doctor, but we'll look at it from different eyes, essentially from the eyes of the machine learning, trying to come up with the same diagnosis. This is not to replace the doctor, this is to complement the doctor. What we do at LatticeFlow is essentially this part here. Are these models actually performing well and as they essentially claim? And this is the part here, is that if the model is not performing well, you will not see a car crashing into the wall. you will have a patient with a bad diagnosis. And this is the kind of the problem in this case. And when we talk about, are these models really performing well, we talk about it both from the practical perspective as well as really certifying these models, where we, for example, won the first competition in the world back in 2020 about formally certifying that these models are doing the right thing. And what is the challenge in this case? Well, one of the challenge here is that when you're training these models, essentially the way it works, you collect lots of data. So you will go to the hospital, you will look at the last 10 years of all the patient records, kind of what is the diagnosis, and this is what you would feed into the model. And the problem is that all this data can have hidden biases or hidden problems, even if it's correctly labeled. And this is kind of what will be then potentially picked up by the AI model, because the AI model doesn't know about biases and doesn't know about all these things. And in this particular case, one of the biases can actually be the fact that there is a treatment made to the patient that is kind of visible in the image. So this is kind of what is highlighted here. And now the question is, well, is this something that is used by the model? And if yes, this is clearly wrong. Like, we should not be diagnosing patient based on the treatment, right? This is a consequence of something of the disease. So really what you have in this case is this what if question, like, what if this treatment was not there? Would the model still work as expected? And one way to check this, I don't know if you see it too well, is literally remove the treatment from the picture. So if I go back here, you can kind of see a bit the treatment. If I go here, now the treatment is removed. Now, this is essentially some synthetic transformation of the image that is removing and essentially replacing parts of the image with something else. And now we can, with these two images, ask the system again and check essentially, do you still think that the patient has some sort of disease? And if now the system says no, clearly there is a mismatch. So either this is really relevant for figuring out, and could be that this is essentially medical condition that is relevant, or could just be that this is this hidden bias of the model, and actually this has to be fixed and reported back to the developers. And naturally the question here is, okay, now we had an idea of what it is, but in general, you just don't know. There are like many other hidden things in the model. And this is where we need systems to help developers as well as users to automate this process. And to kind of see it, how it kind of looks from the machine learning perspective is typically people have this nice idea of I just go, I collect a lot of data, I will label it, I will train my model, I will evaluate, and I will deploy. But this is kind of the nice workflow that people maybe in academia talk, or if people are working in the lab or you are kind of trying out a small model, this is what you would do. But in practice, what happens is once you deploy, you will kind of, maybe you go to sleep and you start thinking about, well, do I really know if the model is working well? Maybe you will start kind of digging a bit more, looking at the predictions, trying to check if it's really doing the right thing. And maybe you didn't find anything, but at some point, the user comes in the good case that is angry because the user figured out that something is not working well. And this is already essentially a problem, because sometimes the user doesn't come, and again, like the patient would have a bad diagnosis. And then if this happens, typically this expensive process of you go back to the product team, you start investigating why is this the issue. Maybe after some time, you come up with the hypothesis that, oh, maybe I think that the issue is in the model because there is this particular type of the bias. Now, the problem is that this is one of the explanations, and maybe the problem is actually in the data, because maybe we switched a new device, maybe the software got updated, or there is some other shift that happened to the data. And the problem is that the machine learning thing will essentially have all these hypotheses of what can go wrong, but not really a good way to check which one it is. So essentially they would start doing this kind of way up types of analysis, trying to figure out whether this is, and this again takes time, this takes money. And after some time, they will figure out, okay, maybe I had the right guess, maybe I fixed it, and then I'll try to deploy it. But ultimately I get backed into the same problem because I'm just fixing some errors that were reported to me rather than doing this systematically. So the bad news is that this is where many of the teams end up, and this is why many of these projects fail. The good thing is that we can actually help them. So, and it's also important from the regulatory perspective, where especially when we talk about data and the labeling, this is actually excerpt from the latest proposal of the EU regulations that is, for example, talking about that the data set should be relevant, representative, free of errors, and complete. And this is now a very nice thing to say from the regulatory perspective. And I would say everybody would like to have this. Again, the main thing is how do we actually achieve this in practice, where, for example, even doctors cannot agree what the, for example, the correct label could be in some of the cases. So this is kind of nice thing to have, but we need a technical way how to get it. So I kind of told you at the beginning that there are these three pillars. So if you kind of look at them back now again, so if you look at the data, what we would really like to have is some way to help teams and users to automatically pick up problems in the data and kind of propose them before the system is deployed such that we can fix them. And this actually has a huge impact. And you probably heard about all this data-centric movement where it's all about the data, less about the model. And this is kind of one statistic that kind of proves it with this kind of 3 lines in the below. So essentially here, the higher, the better. And the 3 lines below are kind of optimizing different model architectures. The 1 line above is about what happens if you actually clean up the data in a proper way. And this is just one example. When we look at the model, this is all these hidden kind of biases, spurious correlations, or things that the model is picking up to essentially still make even correct prediction. And this is why this can be dangerous. Like the model actually can be making correct predictions, and it might look like it's doing better than human, but actually it's not. And again, you would want to have a way how you can find this before these models are deployed, all the way to kind of regulatory. And to make it a bit concrete, let's look at 2 more examples on the model side. So in this case, we'll kind of move on from the medical to essentially car damage detection that is used very heavily with car insurance companies, or in general insurance companies, where kind of the problem is we have a lot of images of cars. For example, people taking with their phones essentially pictures around the car and sending it to the insurance company. And the goal of the system is to predict, is there a damage or is there not a damage? And again, the main problem with the systems is that the way we would typically kind of evaluate them and decide whether the system is good is kind of looking at the aggregate accuracy of the system. Like, oh, the system has 98% accuracy, meaning it's good for 9 out of 10 examples. But in practice, what actually can happen is the following. So if you kind of look at some of the examples in the data, again, you can see that the way people, for example, take pictures if there is a damage is that, for example, they start pointing at the damage. And it's a very natural thing for people to do. Or they even would open a Photoshop and start circling things to kind of point to whoever is looking at the picture. And again, this is kind of hidden bias in the data that the model learns, and it will learn to, for example, essentially detect fingers in the image rather than the actual fault. And it's exactly the same problem as we see in the medical. And it's exactly the problem is that not all the images and not all the damages have fingers. Like this may be 1% of your data, this may be 0.5% of your data, but it's there and the model can and might pick it up. And your question is this actually happening? And can I figure it out? In the same way, another type of bias might be, again, kind of very human-like, where if there is a damage, not only I put the finger, but maybe I zoom a bit to kind of show it in a better way. Again, this is another hypothesis that I might have, and I would like to have a system that can very easily check whether this is a problem or not. So again, in this case, if I actually go and check it, I will again figure out that actually it is a problem. It's something that the model picked up and is biased and is affecting the predictions. The main part here would again be, how can you do this in minutes rather than now going labeling half of my data set? If it's a close-up, is it something further away? Because this is what takes time. In the same way, so this is on the regulatory side, but this is typically later on. So essentially, I mean, depends. Like now there is lots of regulations coming in. Maybe the one that I showed you would actually be approved next year. And then this would not be later on. This would be like, you have to already do it. But the way I look at it, and then we will have a panel discussion later on, is that this is kind of people upfront are trying to formalize some set of good practices, hopefully, that the company should follow. But in ideal world, these are good practices that the companies are already following, because this is something that helps them build models that are better, more trustworthy. So this is kind of just trying to prevent companies potentially being lazy and not doing these things in a formal way. And we've seen it many other areas, such as in medicine, where there are very strict FDA approvals for getting these things to the market, which is very good ultimately for the consumers. It's all about the level of what is the balance between being good for consumers and kind of being restrictive in terms of the market. And maybe lastly, if you look at data, again, it's all about how can we quickly find issues and kind of fix them. In this case, we can look at another domain for worker safety, where we're literally trying to predict, is the person wearing a helmet or is the person not wearing a helmet? And if the person is not wearing a helmet, someone has to run and kind of kick him and say, like, hey, like, this is not safe. And one of the problems here can be that when we look at the data itself, for example, you will start noticing that we have images like this, where there is a person that is kind of wearing a helmet, but it's cut off. So you can see it a bit in the top left corner, but essentially we should either remove this image from the data, or we should adjust the cropping such that the helmet is properly included. And the main challenge here is that you might see one image like this, but ideally you want to go through all your data set, find all the images in the same issue, and essentially bulk change the annotation or bulk remove them. And this is, again, from the technical side, what you would like a system that actually helps you automate this process achieve. So you would go from one image to all the similar images with a similar issue in your data set, and you can quickly fix it. Okay, so this is roughly what we are working on, really ranging from the data to the model all the way to the regulators, supporting the full life cycle of companies. And I'll be happy to take more questions if you have some. Thank you.
Thank you very much for the presentation. So yes, what I immediately think of now is what about the actual mitigations of this problem? So I guess the most common production feedback that one can get is about, like, yeah, we found this blind spot in the model. This doesn't work when there is a lung drain or for a red car. So what do you do in these cases? What's the typical practice? Do you add this to the training data and then restart the development process from? Yes, whatever you can tell about this, I'm interested.
Yes, this is very common. So, and this kind of goes in line with the data-centric view, where essentially most of the fixing is not in the model. Most of the fixing is, I should add more examples in the data. The main thing is, what example should I be adding? So if I just add examples at random, I'm not going to fix this problem. So I have to be very targeted in what it is. There are other ways where you can actually look at the model as well. And we have a lot of work about reasoning about the internals of the model. And for example, figuring out which part of the model is actually responsible for this mistake. And for example, almost like turning it off, and you can do it then without retraining, which is also much more efficient, especially for big models at big companies that spends like 2 weeks retraining the model. And then you can essentially avoid this as well.
Thank you. Do you have experience with this car accident? How long is it from the accident until the case is closed?
This is not something we do. So we are working with car insurance companies that would have this workflow. What we do is help them essentially build these systems.
Okay.
So this is kind of on the side of the health insurance company. But one of the advantages and one of the values of these kind of AI models is that you can actually do this literally in minutes, because you can send the picture, it gets to the insurance company. There is an algorithm like this that runs and figures out what is the damage or not. It can immediately estimate the damage, and it can already send you essentially a repair bill. And then only if this gets wrong, there is a human that actually goes and checks it. Mm-hmm. So this can really get into minutes if done properly.
Yes, I know the Chinese company are very, if you have there an accident, you send a photo and 1 hour later you have the money on your bank account.
Exactly. This is kind of the level where some of the best insurance companies can actually get it to. Yes.
Thank you.
Pavol, thank you very much for your presentation. I have two questions. First one, do I understand it correctly that if you believe that there is some imbalance, you kind of see it manually and then you make a suggestion? Or is there anything that automatically detects that there is some wrong inflow, like input of the data, inflow?
It can be both. So it can be both, and it depends how you use the system. So in many ways, you might want to have a human who confirms. In many cases, you would actually want to have an automated way that, for example, do some actions.
Thank you. And the second question, if you deploy already the model and it is running, so is there one of the technology that continues to check?
Exactly.
Thank you.
Sorry, I walked halfway into your presentation. I think it's awesome that you mentioned the regulatory perspective, because I think it needs more people like LatticeFlow to be talking about these things. It's one thing to have regulators talking about this, like you said, but then it's people like you. Turns out that regulators, they actually care less about sort of the specific data and model properties, and really look at this almost like very traditionally at a system level and system level properties. So how do you see sort of the link from data and model to the regulatory side? I think that's where we have to do still a lot of work, also in terms of like communicating some of these aspects with people that have maybe not like a machine learning or an AI background more generally.
Yes, and I think, I mean, this makes sense, because the regulation should not be about how you do things, right? The regulation should be about what should be done, and then how is kind of free to everybody to implement the best way possible. The problem is that people in many of these cases still don't know how to do it. And that's then the problem of like, how can you have a regulation if you don't know how to implement it, right?
Okay, when you collect data, like if you take all the data that you collected, when you have some kind of reasoning that the distribution is the same as you will encounter in the wild, right? But if you start when tweaking it, right, you say that, okay, I'll remove all these images with fingers, I don't know, right, or something like that. Then you essentially introduce a domain shift. So that weakens overall argument to the regulator that the system will perform in the wild. So how do you, what is your answer to it?
That's a good question. So, I mean, and it also connects to the previous question. So when you talk about regulations, and again, we will have a panel, the first thing you need to do is specify what is the system actually supposed to do, and what are the essentially, like in automotive, it's called almost like ODD, like what is the domain that where the system is supposed to be working well. And in this particular domain, then you can start reasoning about, is the system actually working? So in this case, the task would be, our system is supposed to not to work where people are putting fingers, and then we are restricting it. Of course, then you can have other mechanisms saying, how can I automatically detect if there are fingers in the image, because maybe users are not following kind of the requirements of the system. So you essentially want to have it robust to the user input as well.
Thank you.
Yeah, first of all, thank you for the presentation. I mean, you made very clear example on how these dataset biases are present in this kind of image recognition problems. You're like, my company works with kind of time series datasets. Do you have any examples of problems and issues? And have you dealt with some experience? Do you have any experience with similar issues that can arise with time series in this sense?
Yes, and actually Rafael here in the audience is a student who did his master thesis with us, and he literally has a paper on time series predictions and how some of these models arise there.
And I mean, like, what kind of problems in the data set were you experiencing, for example?
Can yeah.
I mean, Pavol didn't say that he has a lot of experience with adversarial settings where we just imagine that a setting where an attacker is trying to actually corrupt your data and then do modification. So I guess that would be one of the settings. And actually still works in a time series in handwriting recognitions. And yes, I mean, I don't know if you had that in mind because I think it's a particular application. Yes.
Yeah. Maybe I can.
Thank you so much. Yeah, and thanks for the presentation. I had one question. You have shown different examples from different domains, and are there supposed to be different metrics of the quality of the performance of the actual solution depending on the domain? And are you developing specific metrics for each case, or are you using some universal approaches?
I would say it's both. So we have set of metrics that we believe are good depending on the domain. But at the same time, if you talk with companies, they will also have their own set of metrics. And this can be typically like even 4 or 5 different metrics that are looking at different aspects of the system. So you essentially want to have both and you want to be flexible in both ways.
Okay, thank you.
Thank you. So next, our speaker is Wouter. So this is a clicker for you. And you're online.
Hello. Okay. Hi, everyone. Thank you for coming and thank you for having me. Let me try to first switch the slides.
Tired.
I think so. All right. Okay. My topic today for you is going to be somewhat in line in terms of machine learning, somewhat in line with the previous talk, but it's about text, so it's a little different. So hopefully there's some diversity here. I'm going to talk about the how we solve the problem of marketing analytics, actually specifically the problem of classifying social media mentions, but there you can apply the same technology methodology to everything else, to a lot of other things, let's say. So our PR asked me to put this slide here. I graduated from Moscow State and did some PhD, and basically the last kind of 18 years about that work in machine learning, now in Toloka, leading ML. So, but really I wanted to share kind of the experience of solving this case. And the case was the case which probably many of you actually have in your tasks is, you have a lot of data points. Well, in this case, we had a lot of social media mentionings. And then the question is, how do you make sense of them if you want to somehow say whether they're all like positive or negative? And our customer, yeah, thank you for this dynamic changing. Our customer, basically, they were processing 2.6 items a day manually. Manually meaning, they used human annotation for this, but they actually collected and wanted to process 60,000 items a day, and that's kind of the case. And of course, the answer is going to be build a machine learning model, but there's going to be more to that than only that answer. And all right, and when first a little bit some sort of motivation of why you need to monitor social media. Well, basically, you're a company who tries to grow. Then you want to work on your brand. You want to find topics which are relevant to whatever your company is doing. You want to maybe get some inspiration from some content which was published on the internet, all sorts of different things. And then you're thinking, oh, great, I'm going to solve all these problems with machine learning. And it turns out for many companies, it's hard. It's only 22% of machine learning teams get in prod less than 2 weeks, but actually quite a lot take more than a month and more than even half a year, according to some objective surveys, hopefully objective. And the approach I'm going to share, it works not only for the not only for social media classification, but for a lot of other tasks which you might think about, maybe spam detection, sentiment analysis, the OCR and speech to text, whatever. There's quite a lot. You can talk to me about them after the talk. Just approximate timeline of like agenda for what I'm going to talk about. And I guess let's start with the actual tasks. We have a lot of social media mentions. What do you do with them? Well, the first thing which many people are going to start doing is to classify a lot of, maybe scrape from the internet, classify them into relevant and irrelevant. And then the next step is going to be likely that you're going to classify them into maybe positive or negative sentiment, and you're going to do something with that, right? Maybe if it's a negative sentiment, you're going to figure out, oh, what is this? Is a problem with my software, or is this just some angry customer because they're forever angry, or there's some other reason for it? And basically, I call these answers to data questions. It's like you have data, you are asked questions, like how do you get answers to them? And the question is how? And so I guess it's time to engage the audience a little bit. What's your opinion? Okay, you have a ton of different social media statements somewhere you scraped over the internet. How do you make this pipeline? How do you classify that? What would be your approach? Anybody wants to answer? And it's not me who is going to answer all the questions today, right? Okay, so the goal, so the question in the audience is like, what do you actually want to achieve? Well, what you want to achieve is to find something relevant to your company and improve your company given the social media, stream of events. This is what you're trying to achieve. Like, how would you make sense of it? What's the approach you would take? Yeah. Okay, so the suggestions from the audience is to, thank you very much for your suggestion, is to take keywords and then, find something relevant or not. And basically, I guess a person write some scripts with keywords and try to classify it. That's a reasonable approach. So, I mean, you can imagine that there is one person who is tasked to do this. Basically, I think, you should process all of this. And it works, but it usually works for fairly small volume because this person starts getting overwhelmed and then you start hiring more people. Turns out hiring more people requires managing those people, and it's also expensive to hire those people, even if they write a lot of keywords. And writing a lot of keywords is maybe not that, actually not that precise. So some people actually go with the option of data labeling services, where you don't hire people on site. You actually outsource this task and say, okay, well, maybe I should hire some people, outsource this task of classifying somewhere else. Yeah, Rob? Yeah, so I'm going to get to that. Maybe, but yeah, you kind of could, but it doesn't answer all the questions. Yeah, so this is part of the answer to your question. The question in the audience was, can you use large transformer models? And the large transformer models is actually many other models before. Things have changed, but they haven't changed as much as to be suitable for every single use case. And the key problem with large transformer models or anything out of the box is that they're not suited for your use case. Like, you can have a sentiment which is specifically, maybe specific for your entity or your specific product, or what is relevant to your company is very different than what is relevant to another company. And like picking that model, you got to start working with those models somehow and adapting them to the use case. And of course, you end up very often building your own models, which is quite expensive. And there's lots of machine learning operations and different problems which are going to arrive. So what we actually try to do is to try to help various teams and companies solve this problem by building some sort of a unified framework, which is better than an out-of-the-box model, which is something that adapts to the use case. And then you're telling me, well, you know what, maybe we have one model which is somewhat okay. And then you're talking about this like adaptation, and I haven't actually said specifically about the data drifts, but the previous speaker has. And that's, of course, something that's going to appear in your system is the thing is that data changes over time. And even if you built this model once in Jupyter Notebook and you have these Excel files and someone is processing them, you're going to have some drifts, and then you're going to update your system once a year, and it turns out once a year might not be enough. So there was a very interesting kind of use case, relevant one. It's about customer reviews of the scented candles. And so when COVID came, the whole kind of distribution of this changed, right? Like there's a lot of more of, oh, these candles don't have scent reviews. And this actually means different things for your product. I mean, the fact that some candles don't have scent maybe just means the person caught COVID and your product is still pretty good. And mathematically speaking, you have on the left some wonderful situation where your classifier has split the data. And then on the right, it turns out that some part of the space where this classifier has split the data after the drift is now classified incorrectly. And so it happens with concept drift. Then there is also distribution drift, where maybe previously people were writing in, I don't want to say one language, but like here actually on the right of the slide, you can see there was an Old English and New English. I face this kind of every day at work when I hear Zoomers speak, but like basically that's what you get. I mean, you get a different style of language and you get a distribution shift. And if you basically start asking, well, do they really, these data sets, are they really so different? I mean, sentiment, text, it's all kind of the same. Turns out it's not. If you have, if you actually draw using some embedding methods, draw and try to project this collection of texts into a two-dimensional plane and a projection, and the texts are from different data sets, then turns out data sets are all, lie in different places. So it is a problem, basically. There's some numbers that basically say, I mean, you don't have to read them, but they basically say on the old data it works, and on the new it doesn't. And so maybe for those of you who don't really know what data labeling is, or how you can set up data labeling and kind of what's the essence of data labeling, I'm going to share a couple of slides on that. Data labeling kind of historically is a key product of Toloka, is a key product of Toloka. And Toloka is this two-sided platform which connects your tasks, your requests with the Tolokers. And Tolokers are people who execute your tasks. And so somewhere the platform is in the middle. There's a variety of different advantages. First and foremost of Toloka, first and foremost, it has a very wide variety of Tolokers sitting in very many different places in the world and speaking different languages. And so that helps a lot. And then there's a lot of other quality control tools. You can get more details maybe from me later. But what you do in order to do data labeling is you basically go to a data labeling company and say, well, I want this connection and I want this task to be formulated. In order to formulate the task, you set up a project and you write instructions. And you write instructions, you basically say, please annotate these phrases, these paragraphs. This is what it means to be positive sentiment. This is what it means to be negative sentiment. Or maybe this is what it means to be relevant to me. This is what it means not to be relevant. And then you, wow, sorry, that is a little distracting. Isn't the train going just above me? It's not like, but all right. So and so that's basically what data labeling is. I mean, you connect your request with the people who execute, and then your request has to be formulated in a way of instructions, and hopefully people are going to execute it. Now let's go into the machine learning part of this adaptive model thing, which I was talking about. So let's come back to actually to the process, right? To what a lot of different data scientists share on their PowerPoint presentations is, what is your usual process of building a model? Well, you first have some sort of data, we call it here a client data stream. Then you explain how to label your data. And basically, what does it mean? You explain how to label data. You just basically make sense of your task. You realize what your task is, and then you're saying, well, this is my task is edge cases, and you somehow explain it either in Word to your coworkers or maybe to the people who are going to label it. Then you gather the data, and that's a process called data labeling. And then you prepare data for training by filtering out some bad data, or maybe like actually usually reformatting, which is what many data scientists do nowadays, most of the time. Reformatting data from one format to another, and then you train a model, test the model, and they deploy a model. Basically, bingo, now you're happy. The problem, of course, is that this process actually takes time, especially if you're doing it for the first time. And as I mentioned, there's data drifts through time. And if you don't have infrastructure, and then your model runs in Jupyter Notebook and is never updated, which may or may not be suitable. Very often it's not, because you kind of hope that nothing changes and you don't really track the performance. So what we did was that we took that part, that last part of this process, and said, well, how about we just make it like kind of a box which is adaptable? And so we have this box that, like, we have this hopefully API which is hopefully useful, which allows you to like encompass in one call data labeling, preparation, training, deploying, and monitoring, which hasn't been on the previous slide. And the reason it hasn't been in the previous slide is because previous slides showed the usual process, and the usual process when you just start building ML doesn't include monitoring, turns out. So how does this work? I mean, I'm not going to go into too many technical details. This is probably the main slide, and the main slide like shows two things. One is you have on the top. Oh, wow. Wow. Okay. So you have on the top here. Okay, that's not too intuitive, but you have on the top line, you have a usual process of calling an API, pre-built API for the model. And you have some model hosted somewhere, in Azure, and you have some Kubernetes handling your containers to scale up. And you have an API, external API, you just, ping it. But that's like the top line is like the usual process we have. What we have in addition is that we have this Toloka labeling project set up, and the instructions are set up, so you don't have to do anything to set up the instructions. You don't have to do anything to filter out the performance, because we have it set up. We're filtering the performers according to the quality which is required. And then, so basically parts of the data are constantly being labeled by the human labelers. And the model, as you can see, there's a loop. The model gets retrained regularly and also gets monitored regularly. And as a result, you get the real human feedback, regular monitoring, and regular retraining. There's a certain slide of how to use it. I don't think we need to go to the demo, but if you do go to that website, you can try the demo of various models, including some ad generation models. We hope to enable scenarios 2 and we hope to enable scenarios 2 and 3. 2 is already ready for some cases. 3 is going to be ready later. But like basically in scenarios, how to use it? Well, the simplest way to, if you're interested to use it, is to just basically talk to us. And another one is to go to this website and try out the API and see how it works for yourself. So coming back to the case, of course, I mean, it all comes back to, does this help anyone? Because I mean, the technology is cool, the idea, yeah, fancy, but then it turns out it actually helped. I wouldn't share it if it didn't to the company. To the company I was talking about, and now they're processing 60,000 a day, and that's basically way more volume, and the price per label is super small. And the reason is, when you do data labeling with humans, it's usually more expensive than if you host a model online. There's a couple of more examples of basically the relevance. Like the 3 steps which I showed in the beginning, if you remember, was a relevance, sentiment, and then classification into the cases of interest, like spam or bug or angry customer. So there's 3 cases here. In one of them, the customer actually had a model which, yeah, that's the case. So in one of them, customer actually had a model which was running, but the model was never updated. And with the updated model, they were able to send to for human labeling, only half as many labels. And the reason is when you get a better model, more recent one, it actually is more accurate, and therefore overall you get better accuracy and fewer amount of human labels are needed. That's it. We have QR code where you can ask us or you can ask me, and I'm really happy to answer any questions about this. Thank you.
Thank you very much. So first of all, what do you do when the product feedback is positive? What do you do when the product feedback is positive?
When the product
feedback is classified as positive, is there any action you take or?
Well, so basically for that specific use case, there was also like, there was a real, I mean, this is what you first and foremost report this like collection of positive feedbacks to the product, or to management to say, whether to say how satisfied users are with your system. And by the amount, if you process a constant amount of feedback per say week, then you can kind of feel the sentiment of the social media to your specific product. And another thing is you can split this by different parts of your products. Maybe your company has multiple products, and then you still relate them to one or another offering, and then get the track, like measure the traction of every one of the offerings, for example.
I could probably add, because I used to be on the side of one of the requesters, one of the clients of such solution. What they did is actually the loop when the feedback is positive, then the tweet, for example, or the mentioning is sent to some operator who would come back and thank the customer for being happy or something like that. And of course, that's the one part. The other part is collecting some statistics day by day on the tone of sentiments for every product and etc.
Yeah, I'm asking because I've received in last year a few congratulations email from a team-wide emails where we just have a copy of the positive feedback and we self-congratulate on this. And otherwise, for the fine-tuning scenario, did you mean of continuing the training from the result of the previous training with the additional data, or restarting the whole training with the additional data?
Okay, so the question is, do we do continual training where we we restart training from scratch, or we train on the, or we start with the previously trained model? And the answer is, so let me give you two answers. One is that there is there's two things here. One is, do we start with pre-trained model, or do we start with the randomly initialized model? And in our experiments, it showed that if you start with pre-trained, it most of the times gets better results. But another important topic is, do we only use the new data, or do we use the old data as well? And so that's the whole area of ML right now. Well, at least recently it was popular, called continual learning, where you're trying to keep the model, make the model not forget the old data and only train on the new one. We are just taking all of the data that we have, maybe with some sample, and as a result, it doesn't forget the old data. Or and of course, I mean, some of the old data is forcefully forgotten, but we don't do continual learning.
So there was a question about big transformer models first. So actually, since you are working with this, I was curious, the model, the modern like GTP3, I think it's called, it shows amazing performance. How does it compare to a human Toloka that just gets, the task and essentially can we replace them with just GTP3?
Okay, well, so the question is, there are these a lot of cool news, and some people even tried and are amazed by the capabilities of OpenAI's GPT-3 model. Do we really need human labelers here, or there is no need anymore? I'm convinced that you cannot solve your problems with the GPT-3 model as of now, and there's multiple reasons to that. One is, do you host a GPT-3 model? You don't. That's one of the reasons. So the reason is there's actually one model hosted somewhere in OpenAI, and in order to host such a model, you need to take it and learn how to use it, and then actually host it on multiple GPUs, and that's quite expensive because the GPU machines are expensive, and even if you take some open source models like Bloom, people have reported that they are not nearly as, even though they're larger, they're not nearly as accurate as what OpenAI has, basically. So there's more than data to train the model. There's also smart way of training it, and there's probably some filter of the data which was done on OpenAI, which was good. So one is that it's hard to tackle these models. Another one is, what are you going to ask this model? If you're just going to ask this model the question is is this positive sentiment, negative sentiment? Maybe it's going to answer to you, but is the accuracy really going to be as high as if you train a normal, well, I don't know, say normal BERT or even smaller model? In our experiments, it shows that when you have 500, 1,000 data points, the BERTs start outperforming anything which you get out of this huge model, and that's even for a simple task, right? But then as soon as you start thinking about your relevant task, is this relevant to my company? Then you need more data than for sentiment.
Maybe my question was not clear. So you will keep your whole pipeline as you described it. We train our own model. We do all that. There is one bit in your pipeline where we take a random person who registered on your platform, show them a piece of text that is description of a problem, and ask them to annotate a given paragraph. So can that be done by GTP3? How does GTP3 compare not to model you train, but to a random person who you hired for a few dollars to do the task?
Well, so if you have a diligent person who is trying to work well with your system, it's who is actually trying an honest work to do an honest work for your annotation, the person wins still. If you have 3 people, independent people who are trying to do this, they win more, and they're more accurate, drastically more accurate. Now, another important thing with GPT is that you also need to do this prompt tuning. I mean, you need to actually find the right prompt to ask it for. And I mean, the models which are based on instructions are not, at least as far as I know, haven't been released yet, and there was only one paper. So I'd say we're not there yet. And there's quite a few months or years to there.
Thanks for the presentation. Could you switch to the slide with the whole architecture, please?
Yes, I must.
Yes, here.
Most condensed slide.
So is that something you built for the client exactly like this, and you sell the whole solution to the client?
Yeah. So there's 2 things, right? One is I share this with you because, I mean, if you want your own process, this is our experience, how we built it. Please build yourself, or ask us for opinion. Another one is, if you're not interested in building this yourself, this is what we've built inside. And the reason why I think it can be useful to people is because we have engineers who have been building such systems for many years, and so they're much more reliable. And then there's a whole fault checking pipeline of verifications, and also sort of different additional architecture and around it to make it reliable. And
So what I wonder is how extensible it is. For example, the client wants to add another source of feedback. For example, users also give feedback, not only the crowd, but users. Do you have ways to, feed their feedback to the database and it just automatically is picked up by the model?
Yeah, so basically, let me ask this. So our current system is like, so this current system which we built and I'm sharing with you is has built like in this specific architecture. There's no additional logical inputs you can put to it. You can of course put input into the input data, or basically in the input data you can put something additional, and then there can be some more processing. However, the reason is we kind of just released this, and we are looking for common ways of incorporating additional, say, data points or additional information in a generalizable way. So yeah, let's chat after the talk.
From myself, from Swiss AI Association. So how it's going to go, I'm going to quickly present a model that we're trying to build in a Swiss AI Association on how to certify AI solutions. And then I'm going to invite the panelists up to join me and discuss the importance of probably certification and other topics they were talking about. And of course, your questions will be welcome as well. So first, okay, so what we're trying to build, is a model to look at AI solutions and say, okay, are these AI solutions okay or not? To be very simple, yeah. Are they correct or not? Are they biased or not? Are they ethical or not? And there are a couple of forces that point into the direction that we need some kind of AI certification. And the first one is legislation. I think Pavol has been speaking about AI Act. That's maybe the most relevant for EU, for European Union. I know Switzerland is preparing something on our side, on their side, whatever. There is a big push for AI regulation in the US. Canada is also very, very advanced. China is even more advanced, but maybe in another direction. And of course, there are some, India as being one of the largest AI hubs is also doing really amazing stuff. And the idea is, of course, to look at the regulation and say, okay, because regulators, if you read AI Act, I read through it, maybe one of the few people, it's really boring, first of all. And secondly, it doesn't say much, but it's very long. So, it's getting bigger and bigger every day. So, but I can give you an example from US. So US is talking a lot about ethical AI. I remember I was maybe a few months ago at one big Swiss university where they hosted a legal expert on AI. And the case was, as I'm coming from financial industry, so I'm going to give you this example. So let's say you want to take a credit with a bank, right? And all the banks have risks models that tell you, okay, so can you get a credit to buy a house or you can't? And suddenly there is an agency in US, of course, for everything. And this agency found out that the model gives out the results in such a way that white people get more credits than black people, or put it otherwise, black people get rejected more than white people. And the agency said, oh, it's a problem of a model. And we're going to talk about it, I guess, later in the panel as well. So it's a problem of a model. So we need to adopt a model that black people will get the same amount of credits as white people. And that's the solution for them, right? And they're saying, so the model is not ethical enough because it's biased towards white people, right? So this is one of the challenges that I guess every AI solution is going to have when we talk about ethical AI. But today we're not going to talk about so much about ethical AI, but more about trustworthiness and so on. We're going to talk about responsible AI. So what is responsible AI and what are the key challenges when we talk about responsible AI? So firstly, regulation is going to push all of us to somehow prove that our solutions are responsible. And of course, the customers on the other side, they want some kind of proof that what they're getting for their money for an AI solution is somehow checked. There's somebody proved it, and not maybe only as on a technical level as we've seen before, but also on a process level and so on. So, you know, is it unbiased? Is it human-centered? Does it use, is it secure? Is it reproducible? Is it monitorable? Can we explain its results and so on? So these are the challenges that certification will try to probably address, right? And yeah, how can certification really support the adoption of responsible AI solutions? So the idea behind this is that we use a maturity model. So some of you probably know this CMMI. So this means that how mature is the solution that we're putting on the market? Because there is no like 1, it's mature, 0, it's not mature. It's usually it goes through steps. So we're trying to use the common model for assessment of basically anything to assess AI solution. So we use we agreed on using one of the maturity models, and in this case, so like the first level is, you know, it's incomplete, then it's initial, and then it's like optimizing, meaning like every day we're improving the model, right? And what are we actually looking at when we're talking about, okay, we're trying to look into a solution, we're trying to certify it. So we're looking, of course, at the data. We talked a lot about that today. We're talking about the model. We're talking about the process that's being used. And of course, there is a big part in governance. And that's usually the things, especially about the governance, that the companies are not looking at. So this means, okay, how is our structure? How is our entry control into a company? You know, do some people come to the company that can look at the customer data and they're not authorized to do so and so on? Are we GDPR compliant? Things like that. So it's quite a complex process. And as you can see, you can monitor or look into basically everything. But of course, every solution is not going to get checked in all of these points. That's why we have a maturity model and say, okay, so maybe if we're on the level 3, that should be good enough for some customers. And let me give you some examples, not to be too theoretical. So what can we check? Like system operations. There is a very important concept of human in the loop, right? So is there a human in the end taking the result of an AI and saying, yeah, it makes sense, or it doesn't make sense, or we're going to use a solution and not? And how do we, and is there a process in a company, or is in a process with this solution that we say, okay, there is somebody checking it. Can you prove it? You know, is the person trained to do it correctly, and so on. So this is what's being checked. Okay, data quality we talked, data relevance we talked about. So is the model explainable? Is there a possibility of a recourse? This means, can the customer say, well, that's not correct? You know, do we have a process to catch that problem, right? And of course, do we have an organizational governance, right? I talked about it. Do we have a data that's being checked? Do we have the right organizations? Do we have internal controls? Do we have internal audits? Do we have external audits every now and then, and so on, right? And then, of course, there is, let's say, okay, customer protection. So is it transparent how we use the data of the customers that they give it to us? We talked about, okay, we can use a large transformer model, but still we need some labeled local data to use in a model. So do we have a process to handle it securely and with enough privacy? So then, yeah, is there a bias in training? Do we have the right testing processes and so on? Is there a data drift? We talked about it before and so on. So I will give you an example how a typical question in such a scenario of certification could look like. Yeah. So let's say you get a questionnaire, company, and you say, okay, what safeguards does your AI system have to handle edge cases in an extreme scenario, right? And then you have points, yeah? There are protective and precautionary measures, you get 4 points. There is ongoing research being conducted to ensure that the latest tools are being applied, you know. So the AI system has been tested against adversarial attacks and so on. So for every one of these, you get 4 points. And in the end, the points are summarized and say, okay, you are maybe on the level 2 or 3 or 4 of this CMMI of the maturity model assessment I was talking before. Right? Or if you don't have any safeguards, of course, you get 0 points and probably you will not get far with the system, with the certification. So how the big picture, there is a questionnaire of similar questions that you just saw. There is a scoring, and then the application would get a certification level issued, either silver, gold, platinum, and so on. It should also be tailored to like smaller applications, bigger applications, and so on. So the next step, we're planning a so-called certification hackathon, where we basically want the input of the community on exactly such questions that I presented, right? So what do you think is also relevant to be in such an assessment? Yeah. So here, I'm sure that companies like yours that you presented know it, right? And the idea is not to let the regulators set it, you know, we should set it, the community should set it. So if you have more questions, please check it out on the internet page, write me an email, connect with us in any case. That's it. And now I would invite other panelists to the chairs here, to the hot chairs. Let me just get my together. Maybe just before we start, any questions about the certification itself or the process? Yeah. Yeah.
Thank you. I wanted to ask who would do the scaling and who would give the answers to this questionnaire? The company itself, the managers, you will do it, or some other independent?
Yes. So we took some best practices from other types of certifications, like what IT certification, like CISA or PCI DSS in financial industry or ESG are doing. And the basis is, of course, you're provided a questionnaire and you provide the answers and with some level of detail of or description of the process. This gets checked, again, depending on the level. And of course, the highest level should also get an audit on site. Yeah, but this is really like the top level of the certification.
Yeah, because there will be definitely a question how to ensure that you scale different products.
Yeah, of course. Of course. I mean, there's different. There's like a check and an audit, and
Okay.
Sorry. Thanks for the presentation, Rock.
Yeah, welcome.
Okay, so we have a lot of different rules in different domains, right? So we have one set of rules on how to certify a medical imaging problem, another set of rules how to certify something for automotive, third set of rules how to certify something for aviation, and so on. So is there any kind of harmonization effort?
Yes. So what I'd like to emphasize is this is not going deep into the specifics of a vertical. This is looking at the process. So how do you use data? How do you use model? Do you use the correct testing? Do you have the processes checked? Do you have the security behind? Is your management team okay? You know, general things, but connected especially to the AI solution, right?
But those other things have it too, right? So, for example, in aviation, you have the process of who can enter the building. You have all the same.
If you have sensitive customer data, then of course you should have a process who can enter the building, right? If not, then not. Then that's not relevant. Yeah.
It's just that there are sets of rules that do similar things, but they're different, you know, they're not harmonized. They're different sets of rules. So there is one set of rules that's who can enter a building that I need to satisfy to aviation authorities, to, for example, EASA, and another set of rules that basically enforce the same kind of thing, enforce the same kind of quality, but I need to satisfy to get your mark, you know, and third set of rules to maybe for somebody else. So is there any efforts to have one or maybe say some harmonization that maybe aviation industry can use the same set of rules as automotive industry?
Yeah, I mean, I'm not an expert in aviation, but I know, like, for instance, if you look at pharmaceutical industry and if you look at financial industry, right? They also have their own sets of rules, right? But if you check an IT system from IT perspective of a medical and a financial company, it would be similar set of rules. You are not going detailed into like financial rules or medical rules, right? These are not the case, right? You should just say, okay, we comply with medical rules. We comply with the with FINMA requirements. We comply with that. And that would be it.
Okay, thanks.
We don't want to change that, right?
And maybe to comment on this, I think an interesting bit that we see with the European AI Act now is that there's an attempt to harmonize things actually, but we have a lot of not technical but regulatory debt on our backs, and so I think what we will see, unfortunately, is the opposite, that you have now all the different industries like aviation, medical, automotive. Automotive is working on an extension to ISO 26262. Healthcare, the FDA is working on extensions to what exists already. All these industries are now looking to pull in the content from the high-level European AI Act, for example, and these other proposals. And the most challenging part, I think, is standardization, yes. which, well, we have to see how it actually pans out.
But let's look at what we have now. I know today there are companies who use AI solutions who want that these solutions are certified, but there is no certification process. And what do? Well, they take one of the big four, give them a lot of money, and they say, okay, you're certified, right? That's how it's happening now, and it's just wrong, right? They're not looking at all at what AI is doing. They're just looking at other stuff. They're looking, okay, GDPR. They're looking at physical security. Okay, this is clear.
Or even worse, they are, so the BSI, for example, which is looking at a lot of European regulations. I mean, what they're doing a lot now is taking old applications, trying to apply it to AI.
Yeah,
and a big problem there is that every applicant comes forward with their own sort of proposal, with their own materials. It's not standardized at all. And so the sad thing is that it's really hurting innovation because it slows down processes. Medical companies, really cool tech startups that are trying to bring their product to market, they don't know what to do, and it takes a long time to go through these processes right now.
Yeah, I mean, I gave you an example before. What the US regulator says, you should change the model that it will judge all people equally. So, I mean, the problem is the data, not the model, obviously. So, okay.
By the way, do you have the answer for this problem?
Well, the answer is that we like the community, AI community should say, okay, these are the things we should look at, right? And this is what should be checked in a very good AI solution, right? Maybe there's a technical part we need to check, maybe there's a data part we need to check, and so on and so on. And these are the things that you guys live, right? You work with them every day, or we work with them every day. And I think that's the solution.
So you mean that the answer to that problem, or stated by the random US agency, would be like, it's not a problem of the model if the model is like certified?
Yeah, I mean, they just want to simplify, and they talk about equality and so on the wrong place, right? I mean, if the model was trained on some data, right? And the data proved that, unfortunately, you know, black people don't get as many credits as white people. So, but it's not that we need to change the model. We need to change maybe the society, but that's not our issue now, right? Yeah, should we move on? Thank you all. You'll all have a chance to ask questions later on to our panelists. So I would just additionally welcome Igor Susmel from Lightly AI to our group, and Olga Megorskaya, she's a CEO of Toloka. So we will talk about different things. But first, I would like, since Igor didn't have a presentation, maybe say a few words about your company. What do you do? What are you the best at?
Sure. Thanks a lot for the introduction. Hey, everyone. My name is Igor. I graduated also from ETH Zurich. I did focus on machine learning and computer vision. And at our company, we help actually companies in the computer vision space to figure out what data they should use. So after using tools like LatticeFlow, they figure out, oh, my model is not very good at certain in certain situations. And then the question is, how do we find more of that in the unlabeled data, or how do we find the other potential edge cases? And we focus on that in a really large scale. So for autonomous driving companies, drone companies, or some other video analytics companies.
Okay, thank you very much. Any other things from Toloka you would like to mention?
Well, just to repeat that, Toloka actually initiated as the crowdsourcing platform, and I believe that now Toloka is the largest crowdsourcing platform in the world, covering more than 100 countries and people speaking all the major languages in the world. We have like almost 10 million people registered on the platform and 200,000 people earning money every month on the platform. So it's a huge source of very diverse crowd, and the whole like idea behind our operations is that we like turn and use this energy of minor efforts of different people from all over the world into automated pipelines, which are actually resistant to mistakes of single performers. When you have multiple loops of cross-verification, lots of mathematics under the hood, understanding which judge to rely in a certain way, et cetera, et cetera. And that's how Toloka initially was growing, from this approach of like automated operations on top of the crowdsourcing. And now we are moving like further towards like AI solutions, what Fedor was talking about recently, to cover more of the use cases of the different clients on the platform.
Excellent, thank you. Now I want to change sides a little bit, and I will ask you about customers. So my question is, do customers ask for AI solutions, or they just want solutions? What's your experience?
They want solutions. I mean,
that's actually, we had like experienced this evolution of our understanding, because since we started as a data labeling company, we had the mind for a long time that customers are coming for data labeling. And that was a very, very narrow understanding for us. Then we understood that, at first we understood that, okay, nobody actually comes for the data labeling because nobody understands why do they really need it. Then we thought that people are coming for AI solutions, which was also wrong. As you say, indeed, people are coming with just, I need something to be solved. And that's like the general approach.
Igor, do you sell your solution as AI solution or a solution?
We try to call it a machine learning, or a tool for machine learning teams. We try to not use the word AI except on investor pages. But yes, I also agree. Like, I think in the end, everybody just wants to solve a problem. And I think any company going or any team going beyond a certain stage, they have to show real value. So at one point, just making AI or blockchain or whatever and throw it in doesn't help.
I guess, well, okay, so I guess, all right. For some reason, I don't hear myself. Yeah, so I guess I'll add to this conversation that also depends on who your customer is and what stage they're on in their development pipeline. So generally, when you start, people want to solve problems, and that some people start realizing that they want to solve problems which could be solved with AI, and then they come to ask for AI solutions.
Okay, thank you. Another connected question. So are customers concerned about black box? You're giving them black box solution, right?
I think they are concerned that even what they build is a black box for their customers. So our customers are usually ML teams that build stuff, right? And then they have this concern very often. So we try to be very transparent, and we even have part of our solution open source. We are very close to academia. We show even the methods we use. And I think you guys as well. And I think that helps a bit with making it less of a black box.
Yeah, and I think it's related to the previous question. Essentially, what is the goal of the company? And when we talk about people being scared about black box, what they're really scared about, that they will not know what to do with it in the future. They will not know how to change it. They will not know how to maintain it. So it's about these kind of questions, not about the fact that it's a black box.
How do you address them?
I mean, look, everything is a black box at the end of it. I mean, you start getting into how atoms interact with, between themselves, right? So like really the black box is about whether your customer trusts that whatever issues they might have are going to be addressed. And that's really the key, the key topic here. And everything else is, of course, becoming a black box. So they are concerned when they start, and they're not concerned after, you build trust and realize what kind of needs they actually have and what things they care about.
Well, I would probably add here that what we observe is that hugely depends on like the maturity of technological background of the customers, because like Toloka initially is an open platform where you can like very hands-on, so any customer can build any solutions by themselves, and when we take like very advanced ML teams of big tech, etc., they are very concerned. They are very concerned about having the total control of the process. They don't want any black box. They want to build everything by themselves, and they just say like, give us the tools for that.
So that's a case against transformers.
More or less. Well, but then the more actually AI democratizes, the more companies are starting to use it. And the number of good ML engineers is limited. So the more we go to less mature companies, the less I think they are concerned about the black box, the more they're concerned about the faster like business results. And that brings us to the question of responsibility, etc. Because even when we provide like the black box, it's not like we should always provide some methods of proving the quality of that, some metrics, some tools for the feedback, and etc.
Okay, excellent. So this leads me directly to the next question. So sorry, go ahead. Yeah, sure. So the question was, which industries or which verticals are mostly interested in AI solutions? What do you see in your experience?
Well, let me give two answers to this. I wouldn't focus on industries rather than focus on how technical a company is. And in the majority of the industries, you can find companies who are interested in AI solutions because they don't have the expertise to build those solutions themselves. And so we, on the front of adaptive mods, we're now focusing on e-commerce, dating, and everybody else who has user-generated content. But then Toloka historically handles a huge variety of different industries. You want banking, healthcare, self-driving, just driving.
Okay, thank you. Go ahead, please.
Well, I'm actually eager to share, because when you start machine learning in in the fields where or in teams which don't know about machine learning, that's a huge challenge always to explain to the requester management or whoever, like, is this customer, who is this needed? The way I found to approach this is you focus on the problems the person is experiencing. Like, you focus on their concerns, like, are they interested in accuracy, specific classes, biases in the data, reliability of your AI solution. And then when you start addressing these problems one by one, the trust appears much more. So it is true that there is a lot of there's quite a lot of mismanaged expectations and overhyped expectations of AI is just going to do magic for me. But like, really kind of getting the time to learn the problems helps a lot.
Okay, maybe let me lead with the, sorry.
Yeah, maybe just too quickly. I think this is also connected to the previous question. Are they looking for AI solutions or solutions? And if people come looking for AI solutions, it's much more likely that the expectations are essentially not aligned. And I think typically, I mean, there's definitely a lot of education that has been going on for the last couple of years, talking with the companies. And usually the best way how to assess it is, can you do it yourself as a human? And then if you can, then you can start thinking about how you can automate it. But if even as a human, you cannot really think of a way how you would do it yourself, then this is clearly usually not going to work.
Okay, thank you. Let me lead with maybe a continuation of what we're just saying. So the biggest buzzwords in legal AI or regulatory AI recently have been trustworthy AI, reliable AI, and ethical AI. So let me just say, we're not going to maybe touch ethics today. We do have an expert in our association who deals with ethics. But let me ask all of you, how would you in your companies define trustworthy and reliable AI? How would you, what is it?
Well, speaking about us, I would say that trustworthy is something that you can actually measure and control in a way. And to be honest, I'm really impressed and a little bit surprised by today's content and the lectures that you guys presented, because we as an open platform, we see quite a lot of trends in the industry. We have hundreds of different customers coming to the platform, building some solutions there. So we kind of observe what's going on. And what we've been observing for a long time, like we started with the big tech who are very, very deep into understanding that you cannot develop any solution without constant measuring of the results, retraining, et cetera, But then when we went to the broader market, we saw lots of really very naive cases when people like, oh, I just want to collect some data set, and then I don't care, like I will once train the model, and then I don't care what happens with it, and I don't care how it really works in production. And I think till the last probably year, we didn't see much attempts of like solving this problem. Nobody understood that this is a problem. And we've been telling that, like, if you ask me of what is like ethical or trustworthy? Is that the fact that you actually, once you have deployed some solution, you are controlling and monitoring that it actually works in the right way? And that's, I think, a very important mind shift. And what you are doing is very important, I think, like moving the industry towards that direction.
Maybe to add here, I also think there are some really good efforts that has been taken, especially regarding trustworthiness. One I really like is also companies shared more insights on how the model has been trained. There are these model cards, I think Google or someone came up with, that give you at least some hints what kind of data has the model seen and how should it react. And the other thing with trustworthiness or reliability is also, I often like to think, would I use it myself? Like if you ask someone that works in an autonomous driving company, you can ask this person now, would you put your baby in that, in your kid? And often they would tell you no. And this gives you actually a very interesting
game, right?
insight.
Skin in the game.
Yes, exactly. You have to really think, like, that's the best question, right? Would you do that? And that's kind of the trust you need to have in your own solution. And then you can start expecting others to have this sort of trust. And if you're not able to do this yourself, like, it's ridiculous to expect others to trust what you've built.
I think it's a very good question. I think, especially for reliability, I think one of the reasons of all the AI hype was essentially we moved too fast and we skipped some steps along the way because it was just too easy to take a lot of data, throw it at the models and be impressed that this is now better than human. And now essentially the whole industry is catching up. Like, what are essentially the good software engineering principles that should be in place? Where exactly, as Igor said, well, if I make a new release and I'm in the test line, I update the software, do I actually have the trust that now I'm not going to crash because I just updated the software? And this is kind of, when we talk about reliability, is like both on the engineer side, but both on the user side, how can we gain this?
Yeah, I think it's really important what you mentioned, good basic computer
and this is
principles, right?
This is also what you said. It's in many ways about the process of how diligent we are about testing these systems and having the right way to do it.
Okay, so sorry.
Yeah, I probably add one thing which I think is quite important in my opinion to all the data science practitioners. And this thing is that besides the regular monitoring, it's really important to understand how deep is your evaluation, how diverse it is. And the reason is very simple. Very often we as machine learning scientists evaluate average accuracy and we're done, bingo. Or like, my loss is lower than before. I'm happy and going home or on vacation. But the production stuff is very different. The production level is very different. What happens with trust is that your AI has a great average accuracy and then it falls on some sort of an edge case. Have you thought about that edge case beforehand? Because if you haven't, this is like an incident of loss of trust. And then 2-3 edge cases are hit and you're done. I mean, your great AI with an average accuracy is not trustworthy anymore.
So who is the guilty one if the model performs or gives a wrong answer? Who is the guilty one? You take some customer data, they give you the data, you build a model, the model gives a wrong answer. It can be just, wrong sentiment, which is okay. Or it can be, well, you have a helmet, you don't, but yeah, somebody can die. So who is guilty?
I like the previous analogy about engineering. I think if something crashes, you wouldn't go to Joseph. You were the one writing this one line of code. You probably would rather say there are multiple people involved. And I guess here as well, like it should. I think one big thing we don't do properly is also we usually build the model before we think about how to evaluate it, which is a big problem. And I think it shouldn't be one person or responsible in the end for the blame. There are multiple stakeholders involved, and I don't know how to solve this problem. I would really think about engineering there.
Well, let's say, like, if you have anyone who is designing the system, you already have a person who is designing the process of interacting with that system, and then it can be one person or a team of people and then some sort of a process of building that model for that team of people. And then in my mind, I mean, the better process you have, the less mistakes you're very likely going to make. So I wouldn't say it's the person who produced data, the person who made a model, or the person who deployed the model. I'd say that the process of developing AI or ML can be improved, and the person who makes that process is likely the one who needs to improve it if you have a fault.
Yeah, maybe just to add, I think this is also partly question of expectations, because ultimately the way we are using these models are to solve very hard tasks. So it's also a bit unreasonable to expect, and it's essentially impossible to expect that these models will always be correct. There will always be mistakes. It's about knowing when these mistakes can happen and having a way how to react and mitigate it. When it comes to the actual legal accountability, that's a completely different question. And this is, for example, one of the ways why many of these systems can actually be blocked, because from the legal way, people just cannot decide who is actually accountable. Like if you have a self-driving car, well, who is actually accountable if something goes wrong? And for example, in Germany, I think the latest law is that if they have self-driving buses, there has to be like a operator looking at the video of the bus, and maybe the operator is looking at 10 buses at the same time, but they are kind of shifting the responsibility to this person, and I would definitely not like to be that person.
But it's a human in the loop in the end, right?
Yes, but they're just shifting the responsibility, and it's, yeah.
Okay, maybe one of the last questions from myself, and then we'll try to involve the audience as well. So if there was like AI certification we talked about before, what would be one or two features that you guys from yourself would like to see being in that certification, or what would make sense for you, maybe each one of you? What should certification check?
Well, I totally like the idea that was presented today, that what should be checked is actually the process and the principles on the system level. And that, I think, is quite a universal approach, because there's no point going deeper into the particular applications and particular domains.
I'd also say, like, who is, like, at what point is the decision made? And it doesn't have to be always human, but it has to be very well understood in what cases it is AI, in what cases it is human. And if it's fully AI, I'd be questioning it. So basically my answer is human in the loop. You know, do you have, like, at what moment in your system?
So you would check a process if there is a human in the loop, and at what stage, and so
like
on,
what
level.
Like, does your process include human in the loop, at what stage, and is this a reasonable stage or not?
I think I would also look at different parts. Like, one is the final product, kind of how this works, and then there's also the development process. Like, has everything been considered or not? And I would also bring in the question that we should maybe not only focus on the model, but also the data, because it's really difficult to, you can maybe pick the model with a few inputs and see what's coming out. But in the end, we should also consider, has this data ever seen certain situations, or like, has it been included or not? Just to make sure that there's some coverability somehow.
Yeah, and for me, I think it's really about, it's a process. I mean, there was also a question before, like the regulations, every industry, every vertical has its own specifications, and we need to kind of standardize it. And I completely agree with this, but there is a reason why this is happening, because if we would wait for the standardization, we would wait another 20 years until everybody agrees. So one thing we've seen is really to start from the simple things. And the simple things can be really simple. Like many of the things we discussed today are way advanced. And this is almost at the level, have I even looked at the data? Like, am I even regularly looking at what my system is predicting? And things like this, which almost look trivial, but this is kind of one main role for regulations for people not to get lazy and skip these kind of important steps.
Great. So now I would really invite the audience to ask questions. We have 4 very smart people here and 1 moderator, so you can really ask them whatever. Can we share the microphone maybe?
So a lot of companies, especially smaller ones, rely on open source data sets and pre-trained models as at least as a starting point for their own application. And of course, that's an issue because these models and data sets are not certified. And as you've seen on one of your slides, they have intrinsic biases and errors. So my question is, can your companies contribute to perhaps correcting or certifying even open source solutions that people build off of? And is it possible that one day, just like how electronics engineer can rely on pre-certified Bluetooth modules on their PCB, perhaps ML engineers could rely on pre-certified components and not have to go through the hassle of certifying the whole system from scratch?
Certainly. I mean, this is just a question of who is going to do it. Like, as long as you can, us. I think, I mean, not necessarily us. I mean, we are definitely helping here, but I think in many ways it's a community effort. Like, we are building the technology and other people here as well, but we don't have the capacity to go and start certifying all the models. And especially, I mean, I guess you mean all the things. I mean, again, talking about the lazy things, like one of the things is actually if you download any model from Hugging Face or so on, this is actually a huge security risk because you are actually allowing executing arbitrary code in your code base, which is again, like almost unrelated thing, but it's like one of those easy things that should be fixed first almost.
Well, I would add that actually in Toloka, we do have a process of opening different data sets, and many of participants of our community are contributing in opening the data sets. So there is such a process on the one hand. I do believe that at some moment we will reach the stage when there is kind of enough of the data sets for the basic use cases which are needed for young startups just to start. But at the same time, I do not believe that any open general data set is a really in practice, it is a really solution for your real business. So in any way, it can be like the first step, like the first impulse, but then you always need some adjusting and fine tuning the data for your particular use case and constantly updating it to avoid the data drifts and etc. what we've been mentioning.
This is a really interesting question, and we actually had a very, very long and almost painful conversation with the EU about these pre-trained models, because not only the open source models that you have, but we speak to a lot of companies that build sort of one bigger model, and then they sort of fine tune from that for customer sites or whatever the different use cases. The state right now seems that they really think about this in terms of functional change. So when you look at these bigger models or these open source models, how does the functionality change to that final model that you're going to deploy and that needs to be certified? And if that sort of delta is minimal, then you may actually get away with the certification on these open source models or on these pre-trained models. But obviously, if you introduce changes to that, if we look at a use case in aviation where lives are at stake, then even minimal changes may require recertification. But the important thing is that that's proportional to that delta that you introduce from these open source models or from the larger model that you have towards the one that you actually deploy. So it's a very active discussion, but yeah, it's also a difficult one to have because not everyone is on the same side.
Thanks for the input. And I think that, I mean, this is the case for my company. And like, for example, ImageNet is something you will always pre-train on, and ImageNet has a bunch of issues. And you can't really afford to train something from scratch if you're a young startup. Like, it's just way too costly. So it would be really beneficial to just certify the delta. But yeah, thanks.
I have a question related to the discussion that you had about a solution versus AI solution. It seems that, so is it the correct feeling that I have, that it seems that there will be a harder regulation demands on the AI solutions compared to the usual software solutions. So again, would it first of all prohibit people of going into AI solution just because it will be highly regularized, especially in finance? I'm thinking, and overall, how do you feel about this discrepancy between this, that like if you have a rule-based solution, it can be unchecked and unethical. If you have AI solution, you're thoroughly, prepared. Thank you.
Yeah, thanks for the question. Maybe let me try to answer first quickly. You're absolutely right. And to be honest, I don't like what I'm seeing coming from the regulatory part. So like the EU and US even further, they want to really cripple, I would say, the potential of the AI with regulation. And I think here it's really an important thing that the community can do and maybe fight against it, right? Otherwise, we will not be talking about AI solutions for long.
I work in a bank and I already see this shrinking, even if it doesn't make any reasonable sense. And even we also had a case where we at the beginning we build a binary classification, and there were humans in the loop that were marketing why did they make this solution. And we thought like, so cool, we will do a multi-classification. The problem is that this input didn't make any sense. So it was absolutely impossible to build any solution on it. But I think like somehow it will be maybe from my perspective, very nice to have the same demands on the like regular solutions and the AI solutions. And then, we will go to more ethical things overall rather than just one thing.
Thoughts on that?
I also have a question here, like where do we draw the line between normal solution, software solution and ML or AI solution, which is also sometimes a bit tricky. I think if you have like a deep neural network with many layers, it's maybe simple, but if you have a tree model, decision tree or something, could
they
be
would call
just
it AI.
Yeah.
It's debatable what I think about it, but they would call it AI.
I like to think about these things as just basically compare with our past. And if you think about just factories, I mean, you have machines in the factories and that's as far as you need to go to, I think, answer a lot of questions. I mean, there is certain regulations on what kind of output you can produce from a factory of clothes. There's certain regulation of what kind of machines can stay in your factory of clothes, and you replace the word machine with the word, say, model or how that thing is produced. But you don't have, I mean, do you really have a specific regulation on whether a person, a person built a jacket or a factory has built a jacket? I mean, yeah, and there is a reason for that, scale, right? The reason for it to scale is like the factory gets regulated because they have huge scale and therefore a lot of impact on the around world. So I'd say that as soon as you start seeing immense scale out of AI-based factories that produce something, you're going to start having more regulation on the front of AI-based solutions, if you want.
Yeah, and maybe just to quickly add, I think to me, the question is actually the same as we had before. Is it AI solution or is it a solution? Is it AI regulation or is it regulation? So in many ways, we should be talking about the regulation, not about whether we are using AI or not. And talking about the European one, which is long and not super fun to read, the way they define AI solution is actually extremely, extremely broad. So this would actually cover essentially any machine learning that you can think of. And the difference is if that machine learning is very simple, you can in a way implement the regulation much easier than if you're using very complex methods that it's much harder to reason about. Yes, exactly. If you have 3 if clauses, it would still potentially fall under the regulation. It would be very easy for you to kind of reason about the system because it's 3 if clauses and you can just list them and you are done.
Then you just do not have to do this. Though, like, this part of compliance, internal compliance. Yeah, but yeah, like I work in one institution. Maybe I'm skewed, but I'm seeing.
So both Pavol and Igor mentioned the engineering practices. So with industry customers, would you say that what's your assessment of like the status of engineering standards in the ML community? Would you say that it got worse because of machine learning, the engineering practices? Is this really a challenge that people forgot how to properly just build systems, or is this really a specific issue to AI?
I wouldn't say they forgot. I mean, the main challenge is that they really didn't know how to do it. Like, this is a very new and evolving field, and they are kind of figuring out how to do it as we go. And because it was not a standard software, these processes just didn't exist. And then they need to kind of invent or like figure out what the process is and then start implementing it.
Yeah, can I just add to it? So I see it as well. So you have data scientists, right? They know everything about data science, and then you have computer engineers who have good computer engineering practices. And those two are different, right? So that is the issue. So now we need to teach the data scientists to use good computer engineering practices. I think that's the...
So probably a lot of the certification would be about software as well, I guess, just that they are inspired from it.
Exactly. Like if you look at the typical data science engineer, he or she might work in the Jupyter notebook, run some experiments, and then next week, what was that notebook? What is the version? Like, what was the data I was running? And it's very good for experimentation, but it's not so good if you actually want to reason about what is the result and have a traceability and all these things around it.
Good evening.
Maybe I'd like to add. So your question had an interesting phrase on did it become worse, and I think it's a very, I think it's important to address this, because it's like, well, we invented this new machine for the factory, did everything because, you know, did producing jackets, has it become worse since then? And well, maybe, but it's a really a temporary stage in I mean, you're going to get better very soon, as soon as you figure out the templates for how the machines produce jackets, and you figure out, you know, how to bound their capabilities. And maybe yes, maybe no, but it's not really important. The important thing is that in the long run, it's very likely going to be better.
Maybe one last thing to add here. In the short run, what we've seen is that the expectations for ML people is much lower in terms of engineering skills. So if some like a company has a problem and they think AI is a solution, so they get the next person that says, I can do AI, but maybe that person has not much experience in anything else outside of that field, maybe not even much experience in the AI field itself. And that's then a problem, because I think what's now happening slowly is the expectations go up, as with more people are aware of how do these systems work, how should we build them, develop them, maintain them. And with these expectations going up as well, the quality will go up.
Maybe a few more questions. So I have one question regarding the regulators, is what are actually their intentions? And
make money.
I mean, I was also at this events that you mentioned, and this was like how to not do it. I mean, this was a catastrophe. It's like, and yeah, the related, like I asked a question there was like, are you aware of the unintended consequences of what you're doing? And there, I mean, it's obvious. So maybe you can say something about that.
Yeah, so yeah, we were talking about similar examples, and really smart PhD lawyers from US were explaining how to do things which most of the public thought it was wrong, saying, okay, we need to fix the system because there is bias in our population, which is, yeah, doesn't make sense. And to the question, what do regulators want? Well, regulate.
Anybody?
Somebody maybe hope that save lives, improve society.
If somebody else has another idea, David, maybe
Yeah. Or you go first.
Look, I mean, it's also like what the regulators want, and an answer can be seen in. There is a book called "Strangers in Their Own Land." It's about Americans living in America, and some Americans living in America, and basically the book explores why they vote for Trump, etc. But the thing is that if you don't regulate, bad things happen, and so the regulators want to avoid bad things from happening. That's what they want, right? And then they won't just regulate and collect tax money. I mean, the purpose is to try to avoid unintended consequences and certain things which we don't know could happen.
I actually think that regulators often get a bit of a bad rep, and I don't think it's completely deserved, because they have contributed a lot to society over the last like 40, 50, 60 years. People always worry about the upcoming flight when they are in the taxi, but really it's much more dangerous to be in a taxi than to be on the plane. And that's for a reason. And so things are slow and things don't, work the way that we want them to work, but it's all there for good reasons. Now, what do regulators want? I think there are some subtle issues around that, where when we went like in 2016, 17, tried to talk to people about regulating AI, we were sent home, and they said, yeah, there's no way you will ever certify this thing. And now here we are like 5, 6 years later, and all we're discussing is certifying AI, because there needs to be a process behind this. So clearly things are changing, and we are on the way to doing that. Now, there are a lot of political pressures involved in this, where you have industry governors and industry regulators that are now getting official mandates from the EU to come up with stuff and to adapt their regulatory framework from what they've done for 30 years to this new thing called AI. And it's not a voluntary thing that they're going through. I mean, they're not making any money anyway. They're not like taking on any liability or any of that. It is really more political pressure from all sides to set this up, and not have everyone hate on them.
I'm sorry, I would really add, because that struck me. I remember, I think it was 2018, there was the ICML conference in Stockholm. Maybe somebody of you were there. But I was surprised then, like the half of the conference and the keynotes were devoted to the ethics in AI and all those use cases about those credits and etc. And it was that time a fairly new thing, because before that it wasn't such a mainstream topic. And that I remember that time, like 5 years ago, I came back from this conference saying like, oh, this is so strange. They are talking about fantastic things. How is it possible even to start regulating that? And indeed, today we already are discussing these very applicable things, and those regulation of the design of the system is something very practical and actually very applicable. So now I have a feeling that it's very likely within a couple of years to have even quite a meaningful regulation, which will not only shut down all the innovation, which is always a risk, but probably would really be for the good.
And it's a beautiful example, because ICML 2018 was great, and there was a lot about ethics, but I think it also goes into the question we discussed before, which is like, how is the engineering field evolving? And back then I feel it was purely an academic thing to talk about, and what is like ethics, and all sorts of people gathered around that. But now we actually are forming an engineering practice around this, and suddenly we have lawyers, we have almost accountants, we have everyone talk about this, and it really becomes a thing, and there's a need for implementation solutions to this.
Okay, so the future is bright. This is the and with this, I think we are past our time, and I would really thank my co-speakers, my panelists here, and all of you who came here, and Toloka for organizing it. So
I hope we meet each other again. You have the contacts, I think, of everybody. Please exchange them. And yeah, thank you very much.